How can I consistently graph quadratic functions that have both vertical and horizontal transformations? I will share the order in which I perform my operations, and I will have at least two of the transformations listed involved in each function I demonstrate. Here is some positive feedback from one of my parents. I love sharing this so you know that I am highly passionate about helping others and that I am highly confident in working with you in algebra. When you graph a quadratic function, I strongly suggest that you begin by plotting the vertex. Here is the first of two forms I will show you for quadratic function. Going from left to right, A represents the vertical stretch or compression. When A is less than 0, you have a vertical reflection. B represents the horizontal stretch or compression. When B is less than 0, you will have a horizontal reflection. H is the horizontal shift and K is the vertical shift. Therefore, HK is the vertex. Here's the suggested order. HK is the vertex. Plot the vertex first. Then you can go from left to right. Working with A, you can deal with the vertical reflection and the vertical stretch or compression. Finally, working with B, you can deal with the horizontal reflection and the horizontal stretch or compression. Here is form 2. Going from left to right. A again is the vertical stretch or compression, and when A is less than 0, it is a vertical reflection. That does not change from form 1. B is the vertical stretch or compression. That is the same as form 1. And when B is less than 0, you have a vertical reflection. Now the change is finding H. You have to take C divided by B to get your H value, so you can plot your HK vertex. The suggested order of operations for form 2 is the same as the suggested order of operations for form 1. Just be careful with plotting your vertex. The H value is C divided by B. All right, I have 6 examples for you. In scenario 1, the function we want to plot is g of x. And I have the parent function f of x equals x squared in blue as a reference. Okay, the vertex is 1, 2. Transformation is a shift right 1 and a shift up 2 from the parent function. And we will end up with your g of x function. Scenario 2, want to graph the g of x function. The vertex is 0, 2. So we have a shift up 2 only. Next, we have an a value of 3. So we have a stretch away from the x-axis by a factor of 3. You will see g of x plotted in green. Scenario 3. The vertex is negative 2/3, 0. We get the negative 2/3 from C over B. So we have a shift left 2/3. There is no shift up or down. Our B value is 3, so the parabola is compressed by a factor of 3. The result is the green function, and you can compare that to the blue parent function. Scenario 4, the vertex is 0, negative 4, but we only have a shift down 4. Next, our B value is negative 1, so that's a horizontal reflection across the y-axis. No visible change with that horizontal reflection. Scenario 5, for the g of x function, Our vertex is still 0, 0. We have an A value of -1, so that's a vertical reflection across the x-axis. Flipping the parabola down, and we have a B value of 2. So we are compressing towards the y-axis by a factor of 2. Lastly, scenario 6, vertex is -5, 0. So we only have a shift left. Then with the A value of 2, we have a stretch away from the x-axis. Please post your comments with any questions or concerns you have about the material. I would love to clarify anything and clear it up for you. I have shared on this slide several ways you can contact me to connect with me. Thanks for watching.